Hi my dear friends, welcome back to our YouTube channel. This is your ADC Max. See the heading, Properties of Complex Fourier Transforms. So I am going to derive and introduce a few interesting properties under the complex Fourier transform. So before going to that, what is the Fourier transform? The complex Fourier transform of f of x, this is a given input, is 1 by root 2 by pi, x equal to 0 to infinity. Whatever we have the f of x, this comes here, and this is called the kernel of the complex Fourier transform. Is e to the power I s x. I is a complex number, that's right? And s is the parameter, the real output. That's a real parameter, the output variable. So that's why the output is f of s, because after integrating this with respect to x, the output is f of s. See that diagram? The input is f of x, outcome is f of s under the Fourier transform. That's right? Now, the first property. The first property is known as the linear property. So what's the property number 1? I go a few properties, very standard and very familiar properties. So what is linear property? What is linear property? Let it be the Fourier transform of f of x is equal to f of s, and the Fourier transform of g of x is equal to g of s. Okay, there are two functions, f of x and g of x. Then the Fourier transform of a into f of x plus b into g of x is equal to a into the corresponding Fourier transform of f of x plus b into the corresponding transform of g of x. Where a and b are constant. Now how to prove this? So this is very simple proof. Let's go for the left hand side. So by the definition, in the place of f of x, here I have a into f of x plus b into g of x. So this is equal to 1 by square root of 2 pi integral 0 to infinity a into f of x plus b into g of x into e to the power I s x into dx. So let us split up this into two separate integrals. So 1 by square root of 2 pi integral 0 to infinity a into f of x. So f of x e to the power I s x into dx. So this is coming a in front of that. Similarly, b coming in front of the integral. So 1 by root 2 by pi integral 0 to infinity g of x into e to the power I s x into dx. Is right? Now this is exactly looks like the definition of the Fourier sine transform. There is Fourier transform of f of x. So Fourier transform of g of x. So it's a into Fourier transform of f of x plus b into Fourier transform of g of x. So what we represent? Fourier transform of f of x equal to f of s, right? And Fourier transform of g of x is equal to g of s. So is equal to right hand side. Hence prove the linear property. Because a and b are the arbitrary constants. Clear? A and b are the arbitrary constants. Hence the linear property. Hence the linear property. Got it? So this is the first property, is a linear property. The second one, property number 2. Property number 2, it's called sifting property. It's called the sifting. Even though you may come across some standard properties under the Laplace transform, yeah, linear property, sifting property, change of field property, everything there. Yeah, yes, it is the same properties we are going to discuss under the Fourier transform aspect. So what is the sifting property says there? If Fourier transform of f of x to f of s, then Fourier transform of f of x minus a is equal to Fourier transform of f of x minus, it is shifting, x minus a is equal to e power I s a into f of s. E power I s a into f of s. So what's the proof here? Let's go for the proof of the shifting property. Yeah, I can go for the proof now. The left hand side is equal to the Fourier transform of f of x minus a. So by the definition is 1 by square root of 2 pi integral x is equal to 0 to x is equal to infinity f of x minus a into e to the power I s x into dx. Here I do some proper substitution here. U is equal to x minus a. U is equal to x minus a. So what about then du by dx is equal to 1. The same time, what about x is equal to u plus e? Now what about the limits when x is equal to 0? Is x equal to minus infinity? Yes, x is equal to minus infinity. I think so, minus infinity. Yes, x is equal to minus infinity. X is equal to minus infinity. What about the limit? U is also minus infinity. When x is equal to plus infinity, u is also plus infinity, right? So this can be converted in terms of the u, the dummy variable. Integral u is equal to minus infinity to u is equal to plus infinity. F of x minus a u e to power I into s into, what's the x now? Here x is equal to u plus a, so u plus a. What about dx? What about dx? Dx is equal to du. So think of du. So e power isu, this is f of u. So this can be split up into e power isu into e power isa. So the integration is only depends upon the u variable. So this is the free from the u. So can you take outside? This becomes e power isa. The balance looks like 1 by root 2 by pi. 1 by root 2 by pi. Integral minus into plus infinity f of u e power isu du. It's nothing but Fourier transform of f of u. Otherwise it will be f of x. U is the dummy variable. So this is nothing but e power isa into f of s. So this is the right hand side. Hence the shifting property. Hence the shifting property. So I do one shifting. What's shifting here? X minus a. A is some scalar. I can shift the axis by a scalar a by x minus a. So that's the answer e power plus isa. E power plus isa into f of s. That is the shifting property. Now by using this shifting property, I would like to derive or introduce one more third property. It's nothing but what is the product of? What is the product of? What is the product of? So the property number 3 here. What is the product of? What's the product of e to the power I ax into f of x? So already we know Fourier transform f of x, this one. What's the product of the exponential term along with the function? So the answer is f of s plus c. See that? F of s plus c. The same manner, if it is here minus means we get here minus as well. Okay? So how to get this question now? A very simple concept. Yeah. Once we go for the proof of the property number 3. So the left hand side is equal to Fourier transform to the power minus iax into f of x is equal to e to the power iax into f of x is equal to. I'm going to use this f of s plus a, yes, by using the property e power iax f of x. So by using the definition, yeah, we can go for the definition. What will happen? That nothing but 1 by square root of 2 pi integral minus infinity plus infinity. This came to the power iax into f of x, the given input function, and e power isx is the kernel of the transformation dx. When we combine these two exponential terms, what we get? 1 by square of 2 pi integral minus infinity plus infinity f of x into e to the power iax isx. So I into s plus a into x dx. So this is exactly looks like the Fourier transform of f of x, but here s means the output is s. Here s plus a. So in the kernel of the complex Fourier transform, this will the deciding authority. It has the deciding authority to what will be the output. So here it is s plus a. So that's why it is f of s plus a. So this is the right hand side. So hence the third property. So very simple concept. Just by using the classical definition, I am bringing this one. And once again, suppose what's the Fourier transform to the minus iax? What happened? It will minus iax into f of x. Then the answer is f of s minus a. Yeah, right. You get e power minus I, so this becomes plus I. When you take the I outside, so it becomes s minus a into I. So that's called the s minus a. So that is the similar way we will prove this result as well. Okay. So this is the property number 3. Property number 3. Fourth one is called the change of scale property. Change of scale property. What is change of scale property? When you change the x by ax, if you change the x by ax, the Fourier transform of f of ax, you get 1 by a into f of s by u. The a is a positive constant. Where a is a positive constant. It's called change of scale property. Once again, go for the left hand side. Fourier transform of f of ax. So by the definition, 1 by square root of 2 pi integral minus infinity plus infinity f of ax into e to the power I x into dx. So we cannot proceed furthermore until otherwise we are going to take ax is equal to some dummy variable t. So by that way x is equal to t by a, otherwise dx by dt is equal to 1 by a, otherwise dx is equal to dt by a. What about the limits? When x is equal to minus infinity, t is also minus infinity. When x is equal to plus infinity, t is also plus infinity. See that? When substitute x is equal to minus infinity is minus infinity. Plus infinity, plus infinity. So now this equation becomes, the left hand side becomes, in terms of t now, root 2 by pi, integral t is equal to minus infinity to t is equal to plus infinity, f of ax. So what's f of ax? So according to my consideration, f of ax equal to this, ax equal to t, so this f of t, e power I s x, what's the x here? T by a. So it is t by a. What about dx? Dx is dt by a, where a is a positive constant. Because if a is 0, what happens? Anything by 0 becomes infinity, so that's why we can avoid this case. Okay, a is the constant, so we're going to take the outside, 1 by a, yeah. So 1 by square root of 2 pi, it's clear. Integral 0 to infinity, yeah, minus infinity plus infinity. Here t is the variable, f of t, e to the power I, s by e. You can combine, you can rewrite this by s by a into dt. So this is looks like the Fourier transform of f of t, but the output is depends upon the kernel. Here is s by a, so that's why the output comes 1 by a into f of s by a. So this is right hand side. Hence the change of scale property. Hence the change of scale property. That's right. Hence the change of scale property. So these are some standard properties under the complex Fourier transforms. And we have one more property under this complex Fourier transforms called modulation property. I made separate video for modulation property. Please go and watch. You should get the really amazing. It's amazing actually, because it's called a modulation property which will give you varieties of results. Thank you so much for watching our YouTube channel. Subscribe our YouTube channel, follow and recommend to your friends. ADC Max. Thank you so much. Take care. Bye.